The majority of the asteroids in the solar system reside in the main asteroid belt, which is between the orbits of Mars and Jupiter. And if they all stayed there, they would be a fairly fascinating target to study. But a fraction of them actually orbit on orbits that bring them much closer to the Earth. And these pose, in fact, a potential danger. Should an asteroid of a size, say about 1 kilometer or larger, cross the orbit of the Earth and at some point actually impact the Earth, such an asteroid would incur great damage. So we're talking about city destroyers, continent destroyers, and so forth. The traditional way to detect asteroids is to take a very long and deep exposure of the sky, and then because stars appear stationary in that exposure, but the asteroid appears to move, the asteroid will leave a trail on your exposure, and this is the telltale sign of an asteroid detection. So we're looking at a demonstration of the technique using a known asteroid. This is a short exposure in the top left with stars in the galaxy, and the Spain dot with a circle in the middle is the known asteroid in a 2-minute exposure.
Okay, and the next one?
The next one we do now a 30-minute exposure, and you can see how you see many more stars. You see the same ones and many more, and you see the asteroid itself is now trailed. So you actually go deeper in terms of stars and galaxies, you can see, but you don't go deeper in terms of asteroids, you can see.
Okay, number 3.
And number 3, we're actually showing our technique now. We've taken exposures like this, many of them, 30 2-minute exposures, and what we have done now is we have shifted them along the known motion of the asteroid. So you can see now the stars are trailed, and we actually don't go much deeper in terms of stars that we can see, but we see the asteroid much more clearly. Whereas it may sound simple, instead of taking one deep exposure, you take a lot of short exposures and you just shift them and stack them. The key challenge here is that we actually do not know which way these asteroids move exactly. So if we knew the asteroid motion, we could align all of our images exactly along the track of the asteroid. But the key, of course, is to find new ones as opposed to study the ones that are known. So what we have to do in this case is guess a whole lot of times what the potential direction of motion and speed of the asteroid is. And we do this blindly. And unfortunately, this cannot be done on a laptop. It can be barely done on a powerful desktop, but with a supercomputer, such as we have at the University of Western Ontario, or through the Compute Canada network, we can actually do this in a fairly short order. We can do it so efficiently, in fact, that we can not only now study asteroids in the main asteroid belt, the ones that are more than 2 astronomical units away from us, but we can actually deploy this technique to study near-Earth asteroids, the ones that are potentially hazardous.